Okay, so today we're going to be talking about quotients or fractions with radicals. We're not going to be doing this activity. If you want to do it on your own, you can. But here's something to know about fractions. You know that we can't divide by 0, so we can never have 0 in the denominator. Some other things about fractions is that you can never have a square root in the denominator. So when we see a problem like this, 3 divided by the square root of 12x, we need to get rid of that square root of 12x. We cannot leave it like this. The only way for me to do that is to multiply the numerator and the denominator by the same thing. We're going to multiply the bottom and the top by the square root of 12x. Because doing so is not going to change the value at all, because square root of 12x over the square root of 12x is essentially, if I simplify just that purple part, that's just 1. So what I'm doing is I'm multiplying 3 divided by the square root of 12x by 1. So I'm not changing the value, but I'm going to change how it looks. So let's focus on the denominator for a second. Square root of 12x times the square root of 12x. Well, let's think about something else. Let's say if I had the square root of 2 times square root of 2. Well, square root of 2 times square root of 2 is 4, and we know the square root of 4 is 2. So square root of 2 times square root of 2 essentially is 2. Square root of 3 times square root of 3, well, that's square root of 9. Well, we know square root of 9 is 3. So square root of 3 times square root of 3 is 3. Hopefully you get the pattern here. Let's try one more. Square root of 5 times square root of 5 is square root of 25, which should be 5. So for all of these, now we can hopefully simplify this and see the shortcut. That square root of 2 times square root of 2 is 2. Square root of 3 times square root of 3 is 3. Square root of 5 to square root of 5 is 5, and so on. So square root of 12x times square root of 12x will be 12x. In the numerator, now this is very important, do not distribute. Do not put the 3 times the square root of 12x and say it's a square root of 36x. That is wrong. The thing about the square root is it's like a box. We can take things out of the box, but we don't want to be putting things inside of the box. So the 3 I don't want to put inside that radical. I want to leave the 3 outside the radical. And for the time being, the square root of 12, or the 12 is going to stay under the square root there. Now before I can say that I'm all finished, I want to make sure that that square root of 12x cannot be simplified any further. Because you always want to make sure that we reduce our fractions. And you can see that 3 over the square root of 12x, that's going to be able to reduce. But let's see about that square root of 12. If you don't know what 12 would break down into, do a factor tree. So 12 breaks down to be a number of things. Let's do 3 times 4. 4 breaks down to be 2 times 2. So remember, I'm dealing with the square root of 12, so for every 2 of the same number, I get to take 1 out. So I get to take out a 2. So square root of 12x breaks down to be 2 times the square root of 3x. Okay, so 3 times the square root of 12 is what I had originally, 3 times the square root of 12x. Square root of 12x simplified to be 2 times the square root of 3x. Well, I still have to multiply that times a 3, all divided by 12x. Okay, now let's simplify this. The numerator can simplify to be 3 times 2 is 6, times the square root of 3x over 12x. Ignoring the square root of 3x for right now, that 6 and the 12x reduces. 6 goes into 12, so this reduces to basically 1/2. So this would be square root of 3x over 2x would be my final answer. I know that's tricky, but let's look at another one together. Here we have 5 divided by the square root of 45x. Again, the first thing I want to do is I want to get rid of what's in the denominator. I want to get rid of that square root in the denominator. So I'm going to multiply the top and bottom by the square root of 45x. Okay, so now from here, remember, just like that pattern that we looked at above, square root of 45x times square root of 45x will just be 45x in the denominator. In the numerator, I have to simplify this piece, whoops, I want to simplify this piece to see if that can simplify any further. So the square root of 45x, well, if we do a factor tree, we know that 45 breaks down to be 5 times 9, and 5 is prime. 9 breaks down to be 3 times 3, and those are both prime. And this is a square root, so for every two of the same number, I get to take one out. So let me write this like this, maybe it'll be easier for you to follow. The square root of 45x is going to break down to be 3 times the square root of 5x. So if you notice the difference between these two steps is that the square root of 45x is what we simplified over here. That simplifies to be 3 times the square root of 5x. We still have to multiply that times the 5. And then we're going to reduce the fraction. Well, 5 times 3 is 15. And 15 over 45, well, 15 goes into 45 3 times. Or let's say if you didn't recognize that, let's say if you just saw, well, 5 goes into both of those. 5 goes into 15 3 times, and 45, 5 goes into there 9 times. Well, 3/9 can still be reduced. 3 goes into 3 1 time, 3 goes into 9 3 times, so our answer is 1 times the square root of 5x. It would be better just to write it as square root of 5x over 3. And there's your final answer. Okay, now with the previous examples, we just had one term in the denominator, just the square root of 45x, or just the square root of 12x. Well, what happens if we have something like this, or we have 4 plus the square root of 7? It's a completely different process. We're going to have to use the conjugate. Remember, we've talked about conjugates before, but if we have a plus the square root of b in the denominator, we have to multiply both the numerator, this is important, so let's highlight this, multiply both the numerator and the denominator by the conjugate. Which would be a minus square root of b. Okay, so let's look at some examples. Let's say if I had 2 plus the square root of 3, the conjugate of that would be 2 minus the square root of 3. If I had 7 minus the square root of 12, the conjugate of that would be 7 plus the square root of 12. And you'll see in a minute why we do that. Okay, so let's look at this example. Here we have 3 divided by 4 plus the square root of 7. So I need to multiply, just like we just talked about, the top and bottom by the conjugate for minus the square root of 7. Now remember, when we multiply by a conjugate, the whole point of that is the middle terms cancel out when we FOIL. I'll show you the long way for this first example, and then we'll keep it shorter for the next one. We multiply the 4 times 4, which gives me 16. 4 times a negative 7 gives me negative 4 square root of 7. I'm done with the 4. Now I'm going to multiply everything by square root of 7. Square root of 7 times 4 is going to be a positive 4 square root of 7. And square root of 7 times negative square root of 7 is going to be negative 7. In the numerator, multiply everything here by 3. 3 times 4 is 12. 3 times a negative square root of 7 would be negative 3 square root of 7. Now again, let's look back at the denominator. When we multiply a number by its conjugate, we get the middle term where we have the opposites. Negative 4 square root of 7 plus 4 square root of 7 is 0. So really, we don't need to do that. So when we multiply by a conjugate in the denominator, really all you need to multiply together is the first term and the last terms, because the middle terms will be gone. So 4 times 4 is 16. Square root of 7 times negative square root of 7 is negative 7. So when we go to simplify that, 16 minus 7 gives me 9. And then in the numerator, I still have 12 minus 3 square root of 7. Now your book is going to ask you to write it in a plus b squared to c form, meaning we want to take this really big fraction and break it apart in two pieces so we can see if it can be reduced at all. So when I do that, I'm going to take the 12 ninths minus 3 squared to 7 over 9. So now I have two little fractions, and now let's reduce those. 12 ninths reduces to 4/3. 3 ninths reduces to 1/3, so that'll be square root of 7 over 3. So why don't you guys pause the video and try this next example on your own, and then hit play when you're ready to go. Okay, so let's see how you did. So again, we should take this fraction, multiply the top and bottom by the conjugate, which would be 3 plus the square root of 5. And again, we're multiplying by a conjugate, so in the denominator, we only have to multiply the first and last terms. So when we do that, 3 times 3 is 9. It'll be minus square root of 5 times square root of 5 is 5. So our denominator simplifies just to be 4. In the numerator, I distribute the 2 through. 2 times 3 is 6. 2 times square root of 5 is just going to be 2 square root of 5. Break that up into two pieces. So right now we have it as one large fraction. So they ask you to write it in a plus b squared to c form. So we want to break this up into our two fractions. So it would be 6/4 plus 2 square root of 5 over 4. And now we reduce. In this first fraction, 2 goes into both of those. So that reduces to 3/2. In our second fraction, 2 goes into both 2 and 4, so that reduces to square root of 5 over 2. And there's our final answer, 3/2 plus square root of 5 over 2. That's it, so good luck on your assignment. And hopefully these videos help.